Okay, this is the problem that we started on Friday and we ran out of time. It's 2015 number 2. This is a very popular type of question on the AP exam, so it's important that you understand it. Terrell, I hope you're watching because I'm doing this for you. Okay, so here's the picture that they're going to give you, and you have two regions, R and S. The first thing you have to figure out is which function is F and which function is G. So you do have the use of a calculator, so you can just put any function in. I mean, I think this, I think this is the easier function to enter into your calculator. And when you do that, you will find that that picture is x to the 4th, right? So it should look like something like, well, actually no, because look, there's a negative there. So it's going to be concave down and concave up. Sorry, I'm like looking at a million things all at once. So that is g of x, and g of x is going to be this one up here. Okay, so I'm just going to trace g of x in red. Okay? And then that means that f of x, I'll do it in a different color. This f of x over here must be this one. So green is f of x. Okay? You have to do that before you can do anything else. Alright, I don't like this green, so I'm getting another color. Let's go for black. Okay. Alright, find the sum of the areas of the regions R and S. Okay, so we're going to find the area of R, find the area of S, and then you just add them together. Okay, so for the area of R, it's just going to be the integral of the top minus the bottom. Okay, so R is located right here. So the top is the green, which is g of x, minus the bottom, which is f of x, dx. Okay, you need to know what is the limits for your integral. So the smallest x value is 0, and the biggest x value is right here. So we don't have that value. So what you're going to do is on your calculator, under y1 you're going to put this, under y2 you're going to put this, and then you're going to go to second calc, intersect, to find out where they intersect. And you will find that they intersect at 1.033. Okay, so it's going from 0 to 1.033. Okay, so obviously for g of x you're going to be putting this, and for f of x you're going to be putting this. Put that all into your calculator and you will get 0.9974, whoops, 3. Going off the page. Okay, so that is for the area of R. Now we have to do the same thing for the area of S. Okay, so why did we have to split this up? Because the top function is not the same for both regions. Okay, so now we're going to do S. Okay, so same thing, we're going to have an integral, and it's going to be the top. This time the top is going to be the green one, which is f of x, minus the bottom, which is the red, g of x, dx. The smallest x value is going to be 1.033, and the biggest x value is right here, which is 2. Okay, and this is to find the area of S. You're going to pop that in your calculator, and you're going to get 1.0069. Okay, so these are the two areas. The question is asking for the sum, so we're going to add them together. And when you add them together, you're going to get 2.00435. Okay, we always need to round to at least 3 places. So you could round to 2.004, but I would just leave it like this. Okay, so that completes part A. I'm going to erase this. I'm going to go to part B. Okay, so that wasn't so bad. Okay, part B is saying to look at region S. Okay, so we're just looking at region S. And we want to find the volume using cross sections. So the formula for that is going to be the integral, the area of the cross section, dx. Okay, why am I using dx? Because it says perpendicular to the x-axis. Okay, so I am looking at region S, and my smallest x value is 1.033. My biggest x value is 2. Now I need the area of the cross section. Okay, so what shape is the cross section? It's a square. So the area of the square equals the side squared. Okay, so if I am perpendicular to the x-axis, so I'll just go over here. So if this is my x-axis, perpendicular is going to be vertical pieces like that. Okay, so you get another color. Okay, so you're looking in region S, and I'm going to be cutting pieces like this that are perpendicular to the x-axis. Okay, well you can see that each piece is going to be different. So how would I find the length of every single piece? I couldn't, that would be impossible. But what I do know is that each piece would just be the top minus the bottom. Right, so this is the top, this is the bottom, and so each piece just goes from the top down to the bottom. So each piece would be the top, so the top we said is f of x minus g of x. Okay, so that's a side, no matter where I am inside there. So I'm going to replace that for this side. Okay, so I know it looks ugly, but this actually is our area. Okay, so now let's put it all together. Get a new color. It's pretty. Alright, so I'm following along over here. So I have an integral. My integral goes from 1.033. Oh, I already started writing this, I'm sorry. Right here. From 1.033 to 2. Now I need the area of the cross section, which is just f of x minus g of x, all squared, dx. Okay, and you're going to pop that into your calculator, and you should get 1.283. If for some reason you have trouble with your calculator or whatever, you do get a point just for doing the integral. And then the answer is a point. So even if you could just set up the integral, that would be good. Okay, and now finally part C, which we did not get to in class, so I'm going to erase all this mess. Let's just start from scratch to make it look nice. Okay, and let's go for a nice purple. Okay, so h is the vertical distance, again we're only in S, between the graphs of f and g. So this would be h, or maybe this is h, okay? Find the rate at which h changes, so we want to find dh over dt. This is like related rates, right? Find the rate at which h changes when x equals 1.8. Okay, so I can't find dh over dt unless I have h. So what is h? Isn't h just the top minus the bottom? Remember, h is just the height. So the height is just going to be f of x minus g of x. Now if you want to write out this whole thing for f of x and this whole thing for g of x every time, be my guest. Okay, now we're going to take the derivative. So the derivative of h is dh over dt. The derivative of f of x is just f prime of x. And the derivative of g of x is just g prime of x. Okay, so now we need to figure out what happens when x is 1.8. Okay? So we're going to have f prime of 1.8 minus g prime of 1.8. Okay? So you're going to use your calculator for this one. This is the one on the calculator that says n deriv. I think it's at math 8. And so you just have to, this is why it's great to have the calculator, and you could not do this by hand. So for f prime of 1.8, you're going to go into math 8. This is the function, and then you're going to put it in for 1.8, and you should get 2.11628. Then you can do the same thing for G. So here's G. You put it in your calculator, Math 8, put it in for 1.8, and you will get this, 5.928. Okay, so you're going to subtract those, and when you subtract them, you will get negative 3.8117. And the rubric had it as if you found, let me get another color, if you did this setup, you get 1 point, and then if you had the answer, you got 1 point. Okay, and that finishes the problem. So now we don't have to worry about doing that this week.